What if I told you that reality isn't solid? You know, there's a paper by A.F. Slot called The Grand Theory of Universal Dynamics, or GTUD for short, and it suggests something pretty radical. It says that everything we see and touch, space, matter, reality itself, is fundamentally just rotation. I mean, just think about that for a second. The theory really kicks off with this stunning question. It's asking us to imagine that the chair you're sitting on, the device you're watching this on, even your own body, isn't fundamentally solid. Instead, it might just be an illusion, an emergent property of something way more basic, pure, unadulterated spin.
So how can that possibly be? Well, the theory's first big idea is that rotation is literally the most fundamental thing there is. It's suggesting that before there was space, before we even had a concept of distance, there was only one thing: rotation.
The paper uses a really great metaphor to help us wrap our heads around this. Picture the pre-universe as a pitch-black movie theater. There's no screen, no objects, nothing, just the spinning of a projector's reel in the dark. In that state, distance is totally meaningless, right? What we perceive as space, the theory says, only emerges when we start comparing the different rotational states or phases of these fundamental spinning bits. Okay, but if everything starts as just an intangible spin, how do we get, well, this? How does it become the solid world we can touch and feel? The theory actually proposes a really clear process for how that rotation becomes real. For a simple spin to become something solid, it has to cross 3 thresholds. First up is coherence. These individual spinning bits have to sync up and align their phases. Then comes strength. This newly synchronized group has to be powerful enough to start attracting and binding other bits to it. And finally, stacking. Enough of these configurations have to pile up, layer upon layer, until they achieve stability. It's only when all 3 of those conditions are met that intangible rotation finally transforms into tangible matter. Now, at the very heart of this theory is a single, surprisingly elegant equation. It's designed to describe this entire universal process. It's called the G formula, and you can think of it as the master code that governs how rotation builds reality. And there it is. G equals E squared times delta theta squared. Looks simple, right? But what's packed inside that formula is, well, potentially a universe of meaning. So let's break down what these symbols actually mean here. G is the big one. It represents this unifying principle, which the paper goes so far as to describe as an emergent consciousness field. E squared isn't just plain old energy. It's energy that interacts with its own reflection, a process that theory calls self-mirroring. And finally, we have delta theta squared. This is the engine of the whole thing. It's the rotational dynamic, that difference in spin that gives structure to everything. Now, I know what you're thinking. This all sounds incredibly abstract. A consciousness field born from self-mirroring energy? How could you possibly test something like that? Well, this is where it gets really interesting. The paper proposes a fascinating approach, taking the theory from the cosmic to the digital. It seems kind of impossible, doesn't it? How can you simulate the fundamental laws of reality using something as basic as binary code? Well, the answer lies in figuring out what rotation means in a purely digital world. The method they use is actually pretty simple. It's called a cyclic shift. You take a string of ones and zeros, let's say 1, 0, 1, 1, and you just shift everything one position over. The last bit wraps right around to the front, so 1, 0, 1, 1 becomes 1, 1, 0, 1. This simple operation becomes the digital equivalent of delta theta, that fundamental rotation from the theory.
So using this tool, they ran a digital experiment, and the results are fascinating. Compared to a control sequence with 0 rotation, a small rotation caused about a -5% shift. A medium rotation caused a -21% shift. Now, the key finding here isn't just that there is a shift, but the mathematical relationship between those shifts.
And that brings us to this one very important number, 4.10. That's the ratio you get when you divide the medium rotations effect by the small rotations effect. So why is that specific number so important? Well, here's the kicker. The medium rotation angle was exactly twice the small one. So if the effect was linear, you'd expect the ratio to be 2. But it's not. It's almost exactly 4, which is 2 squared. This is huge. It suggests the effect scales with the square of the rotation, providing digital evidence that directly mirrors the delta theta squared term right there in the G formula. All right, so if reality is built on this rotating information, how does a simple one-dimensional string of data give rise to the three-dimensional world that we all live in? For this,
the theory offers a really powerful metaphor.
It all begins with a single, one-dimensional thread of information. Just think of it as a simple line of ones and zeros that contains all the raw data for a system.
Then this single thread is conceptually divided. Imagine you're dealing cards. You take the first bit and put it in an X pile. The second bit goes to a Y pile. The third to a Z pile, and you just keep repeating that pattern. You're essentially sorting all that 1D information into 3 distinct threads representing our 3 dimensions.
And finally, these 3 1D threads are woven together. They interlock, going over and under each other. And this act of weaving is what creates a complex, stable, 3-dimensional structure from what was originally just a simple, 1-dimensional line of code. The paper itself puts it beautifully, calling this the material loom. Our tangible world, it says, is like a woven cloth. Bits and qubits are the threads, and it's through these processes of rotation, mirroring, and stacking that an intricate pattern finally emerges from these simple threads.
And this brings us to the final and maybe most mind-bending part of the theory, its potential connections to the bizarre world of quantum mechanics and the future of quantum computing. Now, these are speculative links, but they're really fascinating. For instance, there are these exotic particles that act as their own antiparticle. The theory suggests this could be a physical example of that self-mirroring energy from the formula. The way physicists braid the paths of quantum particles could be a real-world manifestation of the theory's fundamental rotation, delta theta. And even the methods used to build ultra-stable quantum bits might rely on the exact same principles of stacking and coherence that GTUD says creates stable matter itself.
Which leaves us with a final, pretty profound question. If the universe really is, at its core, informational, if it's built from these rotating threads of data, then what are we? Are we just the observers watching this cosmic loom at work? Or are we ourselves just intricate patterns woven from the exact same code?